And so my guests today are Mary Poppendieck and Tom Poppendieck. We're going to be talking about lean software development. So they have co-authored books including lean software development, implementing lean software development, leading lean software development, and the fourth book, The Lean Mindset, in 2013. So today we're going to be talking about lean, and I think there's a lot that is really useful and thought-provoking for people doing work in any industry. As Mary and Tom are going to talk about, this is not just about lean software. This is not just about building cars. This is really a mindset. It's a way of leading, and it's more important to use those principles than it is to try to copy specific tools. So those are some of the main themes for today's episode. If you want to find links to their website and to their books, you can go to leanblog.org/. So again, our guests today are Mary and Tom Poppendieck. Thanks for joining us. How are you?
Great. And you?
Yeah. Well,
finally passed the heat of the summer and
it's been in the triple digits in Texas where I am at the moment. So it's still summertime. Where are you two coming to us from?
We're from Minnesota.
Okay.
So we're straight north of you.
Yeah.
Cooler up here, but it's still got pretty hot.
Yeah. So I want to, there's a lot we're going to delve into today. When people think of lean software, your names are the ones that I think I hear quite often and come to mind for people. And before we delve into that, I think it might be helpful for people in the audience who aren't familiar with you. You both have interesting backgrounds that would lead you to be experts in lean software. If you can give us sort of the synopsis of where your career started and how you ended up doing this type of work.
Sure. I started out as a software engineer, but I was in the equipment control world. So I controlled big 3M roll good processes with the software that I wrote. Basically, I was a control engineer. But I was a control engineer when control systems were switching to digital, and I could program. So I had been programming for quite a while in a university setting where I was controlling, experiments with some of the really earliest mini computers. So eventually, I was at corporate 3M, and then I moved to a manufacturing plant in order to work there as the IT manager. And while I was there, this was a videotape manufacturing plant. 3M invented videotape, and it was being attacked by Japanese video cassettes. And we switched over the period of about 3 years. We switched from a push scheduling system to a pull scheduling system as a matter of survival. At the same time, we dramatically increased our focus on quality so that we stopped making bad stuff and caught anything that was wrong really fast. And so in this plant, I was told by my plant manager, I was the head of systems, and any system that made information or stuff like that flow was my problem. And I heard about this thing called just in time, and it looked interesting, and it looked like what our competitors in Japan that were producing better, cheaper stuff than us were using. So we studied some of the very earliest books from Japan on by Shigeo Shingo before they were even well translated, and we decided to try it in our plant, and it was smashingly successful. The plant survived for several more years with very competitive and high quality products before 3M finally exited the videotape business. And that's where I got started in lean. And then I went on to more various types of factory-based software at corporate. And eventually I retired, did an early retirement from 3M. And I got involved in, I'll do something. So I did project management stuff. I thought, well, this is kind of silly. What's going on here? What's this like figure everything all out up front and then, have this great big plan and then follow it. That's not the way we did stuff. We were quite successful. So I started trying to figure out what this here thing called waterfall was all about. And I decided that the way we did software could be informed by the sort of ideas that we adopted when we were doing our lean conversion in the manufacturing plant. Stuff like flow, not having big buckets of inventory sitting around, having very rapid conversion of stuff rather than great big long times when stuff sort of sits and gets old and dusty. So I wrote a book eventually, after a year or two of looking at what was going on in the world, saying, if you thought about things if you use those same principles we used at the plant when we figured out how to do lean, where by this time it was called lean, when I was doing it at the plant, it wasn't. We could, software could be done differently and better. And actually, it could be done more like the way I did it when I was a junior engineer, figuring out how to do good engineering. So that's where my first book came from. It's close to 20 years old now. And interestingly enough, it became a classic. And but the ideas, as much as I was able to articulate them, were pretty simple. Lean and flow have some really good, although counterintuitive effects. If you take those good counterintuitive effects and you apply them into a different domain, the ideas, the thought process is the same. The problems that you have, the counterintuitiveness of it is similar. And so if we apply those ideas, we could have a better way of looking at developing software. Mm-hmm. And how about your background, Tom?
Well, I started out as a physics professor at a local university. Part of the teaching at a small school included teaching computer science and digital electronics. So I was well aware of controls and various software approaches of the time. From there, I went to Honeywell, where I worked in the avionics division, making the system supporting the engineering group of the navigation systems work well. While I was there, they started manufacturing just in time. So we had some interface there. From there, I worked for a while with a MRP small company for small businesses. And then I spent the 90s working at a consulting firm, teaching object-oriented development. I retired in 2000 to join Mary in our current undertakings.
And so, and that book that you mentioned from 2003, Lean Software Development, is
right.
The title of that book. And I want to follow up on a couple of things. Like when you talk about things being counterintuitive, like I've seen this in the hospital and healthcare realm, where kind of the way it's always been done, for example, big batches, right? So if you look at the flow of a laboratory specimen from the patient's arm to the lab to getting a test result, the value added time along that chain is maybe 5 minutes for a lot of common blood tests, but it might take 3 or 4 hours to get a test result back.
Yep.
And it's counterintuitive, where it's counterintuitive to people of, let's say, spending a little bit more on labor in one area, shuttling the specimens down to the lab more frequently in smaller batches can lead to huge efficiencies and cost savings in terms of, by improving flow, getting a patient discharged today instead of tomorrow. But so anyway, back to software. Like, what are some of the things that come across to people as counterintuitive or might lead them to be skeptical about the application of lean into software?
Well,
I think the underlying misconception is the idea that when you optimize something, you are probably sub-optimizing overall. People don't take an end-to-end look at what they're really after. And so they optimize each piece which leads them to strategies like big batches, like standard processes and so forth, that lead to a lot of overhead, which they don't take into account.
And accounting systems don't take into account.
Yeah, that's the other driving factor, I think, both in software and in manufacturing. And that is that people that really don't understand it are trying to establish control over something they don't understand. So they put in place metrics that distort activity and lead to huge amounts of waste.
So it's the whole system view, which typically means you got to look beyond your horizon and look towards possibly outside your company, look to the whole value chain. And that's counterintuitive when you have a very strong, my little area has to be profitable kind of a motive. In fact, when we did just in time in the plant, the biggest problem we had was we've worked really hard to reduce assets. You know what? Assets are a positive area of the balance sheet.
Right.
And we messed up the balance sheet. Okay. So how could this be good?
Yeah.
We also worked to think about how to not run equipment if we didn't need it to make product. Well, you know what? That meant that the equipment had more idle time, and all of its time had to be assigned to products for overhead. So the allocation of the overhead of that machine to products made the products look more expensive. Yeah. And so all of those things were counterintuitive to that. We have these local optimizing metrics, almost all about resource utilization. And the concept of maximizing resource utilization rather than maximizing flow feels so right to so many people, but ends up being so wrong.
Yeah, I mean, I think that makes sense I know what you mean, in terms of manufacturing. People will keep the machine running to create something the customer doesn't need because now the cost per part goes down. But then you have parts you end up maybe at some point later throwing away.
Right.
In the software world, that comes out as keep the people busy and keep the hardware busy.
Well, and the other thing it came out in as very long cycles of release cycles. So you would wait for 3 months or 6 months before you went through all the pain of a release, which of course made it more painful. And that got into a cycle where we had releases very rarely and very much pain associated with them. And I looked upon that like the setup time in manufacturing for a machine. Why can't we just reduce the setup time? Well, the setup time in software is this release process. What if we didn't have to do that? What if we could do one piece flow instead? And fundamentally, that's what happens in an agile world is you stop thinking about great big releases with huge setup time and start thinking about one piece flow. And how do we have to organize our software so that that's a safe and reliable and secure way to operate?
Actually, that's what happens in the post-agile world. The DevOps, the continuous delivery, the microservices, the whole cloud environment, that no longer has very much to do with Agile per se.
What do you mean?
Well, Agile was basically a reaction, just like Lean was a reaction to the just doesn't work experience in manufacturing. Agile was a reaction to the heavy-handed control activities in the 90s, the heavy-handed process, the telling people in detail what to do, preventing them from exercising judgment. And that was pretty much overcome in the 2000s.
So one other question I wanted to ask, coming back to the word lean, and you mentioned agile, and my sort of outsider layman's view of agile, think of smaller releases, smaller batches, better flow of an idea through delivery to the customer. So a couple of questions, you kind of go hand in hand. First off, how do you define lean? If somebody, in the software world is unfamiliar with lean, How do you describe that? And if they would ask, well, hey, I already know this Agile thing. How is Lean different than Agile? And I promise I won't play that same comparison game with lots of other terms, but maybe let's keep it to Lean and Agile. What are your thoughts on that?
Okay, so I'm not sure I understand your question.
So how do you define Lean, and how is it different, or how
Okay,
does it
so
fit
as far as, let's start with how I define Lean, okay, because that's the more important question. I view Lean as a way of thinking about how to make decisions and how to improve what you're doing. And it's a way of thinking that values people and values people at the front line and thinks about how to put teamwork in place with frontline teams that can make good stuff happen. And because they are there where the problem is and they can solve it. It's about teaching problem solving skills. And it's about thinking about customers. And it always puts a priority on, from the time that somebody has a problem until the time that that problem solves, is the important metric. So how fast can we get a problem that a customer has solved, not how do we optimize the cost of every intervening piece. So this is really relevant today in a pandemic, because what we saw is our supply chains tied in knots because they were optimized for efficiencies rather than for rapid delivery. And so we have highly efficient, factories making toilet paper for restaurants and travel areas and not for homes. And whoops, all of a sudden we ran out. The supply chain couldn't respond fast enough. Same thing happened with flour. It's because the supply chain was optimized for very narrow slice, not for delivery of, generally speaking, this grain sits here in big silos. I want it in my house. Well, you know what? We don't have the bags we need to package it in. We only have 50-pound bags because we go to bakeries.
Yeah.
And so those kinds of problems came from not thinking about optimizing from the time I want something till I get it, instead of optimizing how cheap can we make every step along the way. Yeah. And most of the supply chain problems in the pandemic were caused by an efficiency optimization rather than a flow optimization. Mm-hmm. And when stuff changes, when stuff doesn't change fast, hey, maybe that's okay. But when stuff is uncertain and changes a lot, then it's not okay. You need to figure out how to respond to the whole problem, not just my little piece, but the whole problem as fast as possible. Because if all I'm doing is my little piece, then a whole big clump of stuff can get piled up before my piece, piled up after my piece. And from the customer out here's point of view, from the customer out there's point of view, from here to here, there's too many of these homes. Can't have those. You need to have flow all the way through, so that the minute that I'm done with something, I can hand it to a downstream process that is ready to take it, that has the capacity to take it, that right. Isn't overloaded. And it's that thing that works in hospitals just as well as it works in factories, just as well as it works in the software development process. Mm-hmm.
And it's not
so that's what I think about Lean is.
It's not just the delay, it's also the learning. The hardest problem in software is figuring out what the right thing to do is. And if you don't have the ability to try something and get feedback rapidly, so you can either do more of it or change or add on to it, you are not going to very rapidly discover what is worth investing your energy in.
So when I started in Lean, the problem was that people scheduled factories for months in advance, but we were making videotape and the demand was changing constantly. In fact, the standards were changing constantly. And the process that we needed was one that could respond to the current demand quickly, not one that could create mounds of inventory between when we were making stuff and when customers bought it. So the minute this high uncertainty was introduced into the stream, we actually could be much more efficient on the top level. Mm-hmm. On the high level, maybe not on the little measurements underneath, but on the high level, when we learned how to respond rapidly to the demand at the end, the customer demand, rather than how to optimize every little step. To me, that's one of the things that's really important in Lean. And the other thing that's really important in Lean is that it's the people who are doing the work who are in contact with the customers, who run the machines, who do that stuff, who know how to fix it and how to optimize it and how to do better. And we need processes that enable them to think and to make changes and trust them, and puts them with team members that have different perspectives so that they can swarm problems and they can have problem solving training so that they know how to go about solving problems. When we started moving decision making to our factory floor people who are working day to day, they're the ones that figured out how to make our plant do just in time. And when I was in the plant, I learned something. When we came up with this idea of just in time, I first met with the plant manager who said, "Oh, we better get the rest of the management team in here." I met with the management team. We did a simulation. They said, "Good idea, but it's not possible for us to do all the work necessary to change the plant. We better get the shift supervisors in, the general supervisors in here." And they said the same thing. Well, there's no way we can figure out all the details of how to make this work. We got to get the shift supervisors in here. And then we did simulations for the shift supervisors. And they said, there's no way we're smart enough to figure this all out. We got to get the workers on the floor, every one of them involved in figuring out how to make this whole system work. And it was a massive change. We could not figure out how to do it incrementally. So we did it over a weekend. And it was highly successful. Many changes to pool systems are not. But in our plant, we predated all the lean consultants, so that was good. We had to figure it out ourselves. Yeah. And those people on the floor, do you think it worked the first day? No. But you know what? The whole process was designed by the people that were doing the job. And they knew the theory, they knew how to fix it. They could immediately implement changes so that they could make the system work better. And the very first week we had, we went from 66% pack out against our plan to 95% pack out against our plan the first week. Yeah. Even with the problems that were there, because the people on the ground who knew the process were the ones figuring out how to solve the problem. And the job of their supervisors was to help them do problem solving and to help them figure out better things to try. And that's the other sort of half of lean. It's respect for the people, especially the people doing the work. And so it's that two things, that constant, the idea of flow and problem solving at the frontline level. To me, that's lean. Now, Agile, you wanted to know, how's it different? Agile generally is thought of as a selection of various methodologies. You do this, you do that, you do this thing. Now, these methodologies are all basically based on some lean concepts, but they tend to be, this is how you have to do things. Lean is never about this is how you have to do things. Lean is about respecting frontline people, teaching them how to solve problems, focusing on end-to-end customer solution with as fast as you can. That's lean. Yeah. And the methodology you come up with probably should not be the methodology that plant down the street came up with. Hey, they're making sticky tape, we're making videotape. We have different problems. Yeah. And so what you have to think about is how do you grab onto the underlying sort of theory behind lean and use that to make improvements, not what kind of rules can I impose upon and put into place.
Yeah. And yeah, I mean, what you said there really resonated with me. When you are engaging people to figure it out together, they have a sense of ownership. And I think they're more willing to iterate and go through those cycles, as opposed to being told, you are going to rearrange those machines, or you are going to do this. Then people can try it and say, well, it wasn't my idea, so we tried it and it didn't work, right?
Well, yeah, it wasn't exactly like that in our plant. It was the people figured it out themselves. Right. They had worked in teams. They had thought it through. They had tried stuff. They had run simulations, and mostly it worked. And when it didn't work, it was just an extension of the work that they'd been doing before we cut over. Okay, here's a problem. How do we deal with it? How do we solve it? How fast can we get past that? And so when the whole cutover was built up by the frontline people, then when we ran into problems, there was no concept of this is somebody else's. They already had in their head this problem-solving approach to their job. And so when they feel that my job is to get the product out the door, and I have this piece, and I have to think about how the overall goal is accomplished, and where my piece fits in and how I interact with my upstream and downstream processes to make sure that, I don't become the bottleneck. When they have that thought process in mind, then you really get better problem solved much, much faster and much more permanently and much more creatively.
And resiliently.
Yeah.
Yeah.
That's another one. Our
Things
client was
change.
highly resilient because nobody told anybody how to do this thing. They figured it out, and they kept figuring it out. So if you're out doing some landscaping, say you're home and you're getting tired of it and you're trying to dig a stump out of the ground and you get so far and you get stuck, what do? Say, oh, I don't know how to go next? No, you figure out, well, maybe I need a sawzall, or maybe I need a little brat. So you start being creative about how you finish the job because you started it. It's yours. It's your land. It's your stump. It's your lawn. You want to get it gone. And I've seen 2 or 3 different approaches in my neighborhood of how this is done. But they're all creative, and they all are based on the resources that person has and in the way that they want to think about the problem. And similarly, when we have problems in the workforce, you got lots of smart people at any workforce anywhere. My plant, the leadership in my plant was absolutely positive that we had the smartest workers in the world in our plant. We were in a farming area. They were farmers or farmer spouses. They could run their own business. They surely were smart enough to figure out how to run a process. And when you have that attitude, then they know you have that attitude. And they say, yep, I'm clearly smart enough to figure this out. And so let's just have at it. And if I can't figure it out, I got my neighbor over there that I play baseball with, and he can help me.
Yeah.
And it's that attitude of these people are smart. If we really want to get stuff done, we're going to figure out how to use their intelligence. That's like so key.
Yeah.
And that's where methodologies drive me batty, because methodologies tend to become rules that people follow. And this is not about rules that people follow. This is about helping people figure out, understand the big picture, understand their part, and figure out how to make the whole thing work and make sure their part works.
Yeah. And I think in healthcare, one of the best examples I've seen, and I've interviewed him here on the podcast before, a dentist in Jacksonville, Florida, Dr. Sami Bahri, who was trying to figure out how to improve his practice that he owned.
Yeah.
And he said he would go to all these different dental conferences where it was all different versions of the same thing. And Jacksonville has a lot of lean manufacturing presence there in different companies. And he went and read the books of Shingo and Ono. He didn't have another quote unquote lean dentist to go and copy from. So he figured it out. And to your point about realizing that all of his employees were smart, he didn't figure it out alone. He figured it out with the staff working in his office.
You're all smart.
Yeah. And they figured it out and they've iterated. But then there's a risk when somebody does that. Others then want to copy what they did. They don't want to copy the figure it out themselves. They want to copy the solutions.
Right. It's not a risk for the people who do it that way. It's the risk for people will not see the hard work that went into it and the thinking that went into it. So there's a big risk in copying. I agree.
And I think one of those risks and a problem I've seen is Toyota describes the Toyota production system as an integrated system. So, right. So if the word system didn't first tip you off to that, they emphasize that it's an integrated system. And I'm curious if you see in software, because in manufacturing, I've certainly seen it. In healthcare, I've certainly seen it. People want to cherry pick parts of the system that seem to make sense. So what would be an example of that in software of lean going poorly because somebody isn't embracing the way of thinking?
Oftentimes it's agile going poorly rather than lean going poorly. Okay.
Mm-hmm.
So as I said, there are a slew of methodologies, big names. I won't name any particular one, but there's 2 or 3 like these are the agile methodologies. But they were developed by people the way that dentist developed his new practices, by seeing what worked. But then people start trying to copy him. Hey, it worked over here. Mm-hmm. CIOs at the time, anyway, in the early 2000s tended to be terribly conservative. So they didn't want to do anything that they couldn't copy from their fellow CIOs. Mm-hmm. So they would try to import those practices instead of saying we really have smart people. I'm sorry, I've never seen a really dumb software engineer, actually. They're smart and they can figure this stuff out if they're allowed. But if they're told what to do and told exactly what has to be delivered instead of saying, here's the problem, here's how we're going to know that it's solved, what ideas can you come up with? That's not been the way software's been done. Software has not been treated like an engineering discipline in which you tell the engineers what the problem is and expect them to go and to solve it. Software has been treated as you tell people exactly what to do tomorrow, and they do their piece for tomorrow, and then you check it in, and then you try the next piece and the next piece. Now, let's just say you're in Santiago and there's an earthquake. Not unusual, happens all the time. And you call in earthquake engineers and you say, here, let me know if my building is safe, and if it isn't, what remediation I need. You don't say, you go exactly here and you go exactly here, and this is how much money I have, and this is exactly how I'm going to inspect my building. That's not your job, that's their job. But we don't treat software engineers the same way. We don't say, here's my problem, and you're the expert, and here's how we're going to know that we're doing well. Go in there with a team of all of the different types of people needed to solve the problem and solve it. And we have historically not taken an attitude towards software engineers, which has created an environment in which we've created a spoon, feed them exactly what they should do, have these smarter people tell them what's next, instead of let those smart people address and figure out the whole problem. If you look at Spacex, which is, I think, fundamentally an engineering firm, as is Tesla, they treat the jobs of virtually everybody like engineering. They have tons of software in any product, but they don't think about software. They think about, we've got a rocket launch and we have to figure out how to make this booster returnable. And we're going to launch every 3 months. Those launches are going to move. And here's what has to happen by this launch. And here's what has to happen by this launch. And here's all of the different teams and what they have to do. And then each team says, what's my best shot at making sure I've got my part done by that launch? And if you watch the video of all of the failures that they had, you would see that they had lots and lots of booster crashes on those early launches, lots of them. And their development process was about an order of magnitude cheaper than any other rocket development project now. And now they can put payloads up in the air for massive amounts, 1 or 2 orders of magnitude less than any other, well organized and controlled and planned process. Because the engineering process is about getting the smart engineers to think about how to solve the problem and to run, stage experiments to integrate everything so that it goes up. And in that rocket, got a lot of software, got a lot of hardware, and you've got people working on a process that really works in complex systems. We really do know how to do complex systems, but there's a reason why Spacex was successful, and that is because it wasn't run by a government agency that would have shot them out of the project if they ever had a failure on a booster. Okay? In engineering, you try things and you figure out what fails when you try things. You don't have to replan and rethink and have success every time. Right. And it's that engineering approach to solving problems that I think that we need to move into the software world.
Well, what Mary described is a pull approach to product development, just like pull approach to manufacturing. And it is extraordinarily powerful. The problem comes not because pull doesn't work, but because pull doesn't go far enough. In manufacturing, it extends within the factory until you get to supply chain thinking. In software, it extends to the certain phase of development of the software until you get to digitization of the entire organization, where the smart people involved are not just the software engineers, but all of the people whose expertise is necessary to make good decisions about how to address the market. Anytime you separate the design from the production, from the operation, you are going to lose critical wisdom that, when combined, can produce dramatically better results and dramatically better resilience. And I think we're seeing a lot of that in the economy today as it's adapting to the stresses of our pandemic and the subsequent economic peril that we find ourselves in.
So when you talk about framing lean and around customer focus, how does a lean software engineering effort better understand the customer needs and flow needs through delivery? This is, I imagine, a push away from, like, I was involved in a software startup back in the early 2000s that lived and died by the massive requirements document. That seemed, see, I figured that would make you laugh, that was a big, huge batch of somebody who was all knowing, putting together a perfect requirements document and then piecing it out. Here, you go build this. That's not what a lean software
I actually have never seen that work. So, just like the SpaceX approach is a problem, you need everybody to understand the goal. The goal when they were developing the booster rockets that could return to Earth was to have a much less expensive program. And in order to do that, you had to have reusable components rather than stuff that fell into the sea or burned up and never were retrieved. Okay. Now that's a very difficult engineering problem. And they solved it with one step at a time, trying to figure out one problem, the next problem, and the next problem. And they overcame each problem. So you have to see that same thing with product development in general. Here's our overall goal. Everybody needs to understand that. Now, we're going to just take a piece of it. And, in software, this is actually pretty feasible, especially if you don't have hardware associated with it. We're just going to do a little piece. And we're going to test it out on real people. And then we're going to do another little piece. And then we're going to test it out on real people. And we're going to find out if it, if our hypothesis works. We believe that if we do this, we're going to get this buying response or this customer response. Whoops, we're not quite there, but 3/4 of what we did is right. So the idea that in software, you don't have to have everything perfectly thought out ahead of time. You have to know the overall goal, and you have to know how you're going to measure whether or not you're heading towards that goal. And then you do small pieces with feedback to the team, and the team takes a look at it and says, okay, that's not what we expected, but there's this interesting response. Let's try something new. So you need to create a feedback loop with short releases all the way through to actual people, especially if you have a pure software play. And then you have to see how your thesis, how your hypotheses work, and you gradually iterate the product. Now, if you look at what Google has done over the last 20 years, that's how they did things. The very first Google thing, I don't know if you remember, back to the late 90s, Google was in beta for 2 years. And we've never seen like beta products on the market before. Like, it was so weird. How can they say beta every time they log in? But that's because they wanted everybody to feel comfortable with the fact that they're going to change it every day.
Right.
If you look at the way that Amazon did its early software development, especially in the 2003, 4, 5 timeframe, they started doing really rapid releases. Like, it turns out they got their architecture so that they could release little tiny pieces independently. And they do it like around the world, every few seconds, another little piece of software is released. So it's that ability to safely and constantly test your thesis with real customers and get feedback, which totally changes the concept of this big requirements documents that somebody all-knowing has put together. I don't care how good they are. They're not going to be as good as what you can learn by trying things.
Right.
And there's always going to be something wrong that they didn't think of. I mean, how can one person think of all of the little kind of unintended consequences that a great big requirements document is going to, visit upon the customers? So if you don't think of everything, or if stuff changes, either one, then that process ain't gonna work. But the process of trying stuff, getting feedback, and oops, oh yeah, guess what? The world changed, so now we have to change. If you have a very rapid feedback loop, all the way from people using it to people understanding what the problem is and changing it, and that feedback loop is fast, then you have that feedback loop between the actual software engineering team and the people using their work, or the people that maybe have to use it as a tool for their work. You need that feedback loop, and you need the ability to rapidly and independently let small teams make changes. Yep. When you have that, and I don't care if it's software or anything else, then you get a lot better results. So I have this thing in my neighborhood. I don't go into stores. I drive up to whatever store after ordering online. I call and they put it in my car. So I haven't actually been inside of another space for, I don't know, since March, mid-March. And at first, there was some really kind of bad and long delay time software that allowed a few customers, maybe 1% of the volume, to do this drive-up stuff, which we call curbside pickup.
Right.
And inside of 2 weeks, stores started becoming extremely capable of having proper inventory online, proper staffing and procedures in the store, proper ways for me to shop, and able to pick it up. And inside of 4 weeks, virtually every single retail outlet in my neighborhood has drive-up pickup. There's cars here. This is a suburb, right? And now you tell me how that got developed. You could tell the stores that had a big, long development process. They took forever and they didn't quite get it right. And then there were the stores that inside of the first week had some improvements, and inside of the second week had some improvements. And you better believe that those stores had teams that thought about staffing, inventory, technical issues, all of those things, all in the same room, maybe 10 of them. And they tried things and they improved a little bit in 2 days, and then a little bit more in 4 days. And they kept asking me, how did it go for you? And I would tell them what was wrong and what was right. And then it would be fixed in 2 more weeks. And the store that got that done the fastest and the best is mostly the only grocery store I use anymore. Mm-hmm. Because they've solved the problem. They solved it quickly. And they solved it in a way that really takes what I'm looking for into account. And so now I think that that's sort of a thing that you can see frequently. If you allow small teams, throw them at a problem and say, by 1 week from now, you had better have every single professor at home teaching and every student able to learn. Now you've got a team of 15 people in a college IT department that have to make this happen. Mm. And they did. In college after college after college, not just in the US, but around the world. It happens. They didn't have a choice. And it wasn't just, there was no process that they were following, except here's the next problem we got to solve. What 5 people can we send at it and go? And it's that very rapid response to emergencies that we could learn a lot from, because it worked, and it worked well. Yeah. So we have to create, an environment in which people look at the whole system, know what they're trying to do the next step, get rapid feedback, and then your product can be very workable. Now, if you have a great big integrated hardware software system, it's going to be a little bit different process than if you have a pure play software only product. But all that means is your hardware thing has to have these integrated events like Spacex does. Your software system can have actual into customer releases, for example, twice a day. And these days, people that are not releasing software, if they have online software every day or so, maybe even every hour, to live to production, are pretty much behind the times. Similarly, I think in manufacturing, plants that didn't learn how to do very rapid response to customer demand pretty much fell behind. And supply chains now in the pandemic that couldn't reconfigure quickly kind of lost out to the ones that could. Mm-hmm. Now the little tiny flour mills responded really faster than the big ones. And pretty much people started buying flour from little tiny flour mills. Yeah.
I want to touch on a few ideas from some of your later books. So 2009, Leading Lean Software Development, and the subtitle, or at least part of the subtitle, is provocative, saying results are not the point. I was wondering if you could elaborate on that.
Results are not the point. So if you're trying to get a plant or a hospital to be good, okay? What, as a leader, you're trying to do is to create an environment in which people are capable of rapidly responding, swarming problems, solving them, and that sort of thing. Whether they do it really fast or exactly correctly the first time is not the point. The point is you're measuring whether or not they learn how to learn, okay? Whether or not they are good problem solvers. To me, the leadership role in all of this is not producing results, it's producing people who can solve problems. And that's the way, in the end, the results come. It's sort of like profit is not the point. Profit comes when you make customers happy. Right. Results are not the point. Results come when your people are good problem solvers and can focus on making customers happy and have the freedom to do it.
Yeah, yeah. Well said. In your 2013 book, The Lean Mindset, you've already touched on, I think very well, lean being a way of thinking, lean being a mindset. There, you talk about how asking the right questions is important. Can you sort of talk about why that is, and how do we find out what the right questions are?
I think if you look at the history of lean, the technique of asking questions is fundamental to leadership. Mm-hmm. If you want results, you can't give people a plan for producing those results. You can't say, this is the result we need. But you can say is, what is it about the way we're working that is keeping us from doing a better job in this area or that area? Now, the person asking the question needs to have a level of understanding of what the problem is to know where the potential for improvement is. And that takes experience, that takes intuition, that takes a deep knowledge of what's going on. But no knowledge is good enough to necessarily come up with answers that are going to be effective in the context of the day-to-day work. Only the people doing the day-to-day work have enough knowledge about the reality of their skills, their environment, their constraints to be able to come up with the most workable approach. But they're close to that piece. They don't necessarily have the context to understand which are the things that are most valuable to look into how to improve. And that's where the leadership comes from. By asking the right questions, you are guiding the organization in a direction that your experience, your broader knowledge leads you to believe is going to make greater improvements. In fact, what's happened in the software world is that the biggest gap has not been the technical implementation of solutions, but the discovery of what are the proper problems to address. Discovery, as in all product development, has become the fundamental differentiator among successful organizations and those who kind of wither because they spend their energy on things that end up not mattering.
Yeah, let me give you an example. We just bought a new mop that sprays stuff on the floor, and used to have somebody clean the house, but that doesn't happen anymore either. And I was looking, and they're all the same price. The handlebar cleaners, and they're all the same price if I look at the new ones. And they all do the same thing. And then there was one, and it was made by a company that won't surprise you, Oxo, which had a way to step on a tab on the floor, disconnect the big mop, and it had a little scrubber. Yeah. And then you could spray and scrub the spots that didn't come up. Instead of having to bend down and do it, I took one look at that and I said, that is solving a problem that I didn't know I had. Now, Oxo routinely does that. They solve problems you don't know you have, because the question they ask is, when I'm doing this job, what is it in that whole surrounding environment of me cleaning the floor that is a nuisance? And it turns out that when something doesn't come up with a mop and is stuck, I have have to bend over, I have to scrub it by hand. Now, people who make mops don't necessarily think about that, but people at OXO ask the question, what is it about the whole job that is inconvenient that we could solve, and add that solution to our product so that it's a no-brainer. There is no other product to buy.
Yeah.
And that happens with many of their products. So they ask a different question. It's not the most efficient way to produce and manufacture this and get the spray thing that everybody has out there.
Right.
It's what problem are we really solving? And what about that environment? What they always ask is, what makes people uncomfortable doing relatively routine home and kitchen things?
Yeah.
And what kinds of things make them strain and stress? And then they come up with ways to solve that problem. And then they find out that when somebody sees the solution, they take one look and say, oh my gosh, that's exactly what I need to have to solve a problem I had forgotten I actually am dealing with.
Yeah.
And it's that asking the right question. It's not about how do we make this cheaper. It's about how do we make the job more, what is it about the job that is uncomfortable that we can add to make this so much better? And you would think in a commodity product of which there are 10 or 15 all the same price in the world, they wouldn't be able to do that. And they do it again and again and again.
Yeah.
So they're asking the right questions.
It seems like a combination of really understanding your customer and challenging the way it's always been done. I have a lot of OXO products. One that comes to mind, a measuring cup for liquids.
Yeah,
I'm sure almost every measuring cup ever made had the measurements on the outside and on the side. So as you're filling it, and then you have to bend down and look.
Yep.
I love their measuring cup. You probably have the same thing where
I absolutely have 3 different sizes. Yeah.
as you're looking down into the measuring cup, you can see the different levels. So I can fill
all
it
of their products.
and I can get a cup and a half of water without having to bend my neck and turn and look at the things sideways. And like you said, in hindsight, it's brilliant. Why isn't every measuring cup made that way? But they're not.
It's exactly the same process that you read about on the Toyota production line, where the job of the supervisor is to look very carefully at the work and see similar kinds of problems and work with his people to figure out how to alleviate the stress and the strain to make the job easier and more reliable.
Yeah.
It's exactly the same thing.
Yeah. So you've gone to Japan. You mentioned seeing Toyota. How
3-4 times.
How has that influenced your view of lean, and maybe more generally as a wrap-up question, how has your view of lean evolved over time, from Japan influence or otherwise?
I have a little influence from Japan. Probably the most striking was when we met a what do you call it? Principal engineer, senior chief engineer from one of the Lexus products, and he told us what a chief engineer does. And he said that their job is to he talked about how they have to understand and get the various people to work together. He had a wonderful description of what it meant to be a leader. And it wasn't anything about getting stuff on time or creating plans or anything like that. It was about welcoming problems. Said if there's no problem, that's a problem. About welcoming conflict. And I found that remarkable. About welcoming disagreement and helping people to have different perspectives on the same thing. And so that's one thing that I learned a lot, and it's always hard, is to say there are many ways to look at a problem, and the more different ways that you have and that you allow to happen, the better. Whereas most times in our country, the product leader is thought of as a person who figures it all out and tells everybody. In this case, it was exactly the opposite. The product leader sets the overall strategy and goal, and then looks for people to figure out how to solve, tensions within it. And I want this kind of price. I want this kind of, it has to be at this kind of price point. It has to have this kind of roominess for families. And those goals compete. They create conflict. And you're not going to have the best result unless you have the conflict, because you got to push against different ways of doing things to come up with multiple different kinds of perspectives of how to get stuff done. I forgot what question I'm answering now.
No, you were answering. How was your view?
Mary gave a talk
how's
at
it
a
evolved?
conference, software conference in Japan once, and she talked about many of the ideas that we've been talking about here this morning. And she was followed by a sensei from Toyota,
Right.
software person. And the first thing that he said was, don't pay any attention to what Mary just said.
No.
You're smart. You have to figure it out for yourself. You can't follow what she told you to do. You have to figure it out yourself.
And that's
So the other thing we've learned over the years is that in software, I thought, in 2000, kind of software was changed a lot, but it was kind of stabilized. But software has changed so dramatically from 2000 until now. And the tools, the available capability, the cloud, all of that sort of stuff. And so I've learned, if nothing else, to be way more flexible and dynamic about, and less dogmatic about how stuff happens, because you can't conceivably survive in the software world if you can't respond to change and uncertainty, because the software world is all about change and uncertainty. And in some sense, I think that's prepared the software technology world a little bit more than others to be prepared for the pandemic, because we spent 20 years learning that the figuring it all out ahead doesn't last long enough to make it worthwhile. And we have to create systems and processes that allow us to respond dynamically and quickly to whatever change there's out there. And there are many techniques to do it. And you always have to do it with integrity and quality. But the idea that rapid response to problems means that whatever people have done 15 years ago, 10 years ago, is pretty much obsolete these days. So I always think of the ideas from 10 years ago are pretty much obsolete this decade, in software anyway, and maybe in other areas. And the ideas from 20 years ago are pretty much, ready to be retired. And so it's constantly creating new ideas, new approaches, new ways to do things, leaning on the various people who are out there now. And there's a lot of young people out there that don't have the kind of experience I have, but I don't have their background either. And we need to figure out how to get all my grandkids' age folks involved in figuring out how to work in this new world, in an age that is very dynamic and moves very quickly. And we need to start taking some leads from them too.
Yeah. It seems like the risk of copying what was successful from at some other organization is that you're copying something that was published 5 years ago and that was published years after they had done whatever they had done.
Yep.
Figure it out for yourself is advice people often don't want to hear, because I'll get questions and emails and I don't know the context, and people are going to ask some really specific question about what should they do or where should they go visit. And I struggle at times to come up with a polite way of saying, figure it out for yourself.
Right.
You're smart. Figure it out for yourself.
Well, I tell you what, when we work with companies, the first thing we do is we qualify which companies are ready to think and which companies are not. And if they're looking for us to come and give them a recipe book, I say, you know what, we're the wrong people. We don't do that. We don't do recipes. We try to give you a way to think about things so you can figure it out yourself. And I think that's really important. And I also, as I want to reemphasize, I also think inclusiveness, getting as many different ideas and opinions. This was what the sensei in Japan, the chief engineer in Japan said, is you need to have different ways, different perspectives. Great conflict makes great cars, he said.
Interesting.
And we're a conflict diverse country.
Right.
And we've got to get over that.
Wow. So I want to thank you.
We have to learn how to have productive conflict.
Productive conflict. Well, yeah, I knew people used to work at Intel. They called it, I believe, constructive confrontation or constructive conflict. But
Or constructive disagreement.
yeah, but that's the thing.
I like disagreement better than conflict because I'm a conflict avoider myself, not always.
Well, Mary and Tom, I want to thank you for taking time to share ideas that are not just applicable in the software realm, but for Lean and for people in general. If people want to find you, your website, and I'll put a link to this in the show notes, poppendieck.com.
You just have to spell it right.
Yeah. Poppendieck.com.
Right.
And again, if you want to just click on a link, that'll be in the show notes. So
I also have a blog called leanessays.com.
okay.
I don't call it a blog because I don't accept comments. It's just an essay.
Mhm.
But leanessays.com might be easier for people to spell.
Yeah, that one
All
is
one word.
how it is. Okay. Leanessays.com. So Mary, Tom, thank you. Thank you so much. And
Thank you.
hope you continue to be well. It seems like you're adapting to these pandemic times, and certainly wish you all the best.
Yeah, we're staying away from everybody. At the advice of my son, who is a scientist and an expert in indoor air quality, who has told me right from the start, stay out of indoor air.
Yeah.
And so he's the one that encouraged us not to go into stores, not to go into any place until we figure out what the issue is. And he's the expert, and I'm really glad he gave us that advice.
Yeah. Well, there's an example of instead of figuring it out for yourself, there is a time to defer to expertise. And
well, one day when I can figure it out, when I have enough information to figure it out, I will. Meanwhile, when my son said, I don't want you shopping because I don't have time to come and help you out if you get sick. Okay, stay out of stores, figure out another way to get supplies because we're not close. I thought, got it.
All right. Well, thanks again.
Thank you.
Thanks for joining us today.
Thank you.